Okay, we're going back to a topic called systems of equations. And remember, that's when you have two equations, two linear equations, and you're looking for that solution that satisfies both of them, which is typically going to be a point. So we did this for graphing, and I want to remind you, most things end up with an answer that's a point, but remember there were two weird things that could happen. One of the weird things is you could have parallel lines so they never intersect and you would have no solution. And the other thing that could happen is you were graphing the line and the second line is on top of the first line. They're the same line, in which case the answer was infinitely many. So there are those two things that could happen. But let's start with substitution with one answer. The answer would be a point. All right, so we're going to do three of these together from this page of notes. And I'm going to go easier to harder. So if you take a look at example number 2 here, the idea here is if on one of the equations, you can get one of the variables by itself. It doesn't have to be the x or the y. It can be either. So in this example, this is easy because it's already ready for you. They're telling you y equals 6x. So the y is by itself. And that means I can now go to the other equation and substitute 6x in for the y. And I'm going to do it for the y because y equals 6x. So 6x can become the y. So it's going to look like this. This technique, substitution, has a lot of algebra equation work in it. And you are going to substitute that in for the y, and now I'm going to solve for x. So I'm going to start by multiplying that right there, which would be positive 18x. And now I just want to solve for x. I've got like terms here. I can go ahead and add them. And now I can just divide both sides by 20. And I'm getting x equaling -1. So you're going to be finding the first letter, in this case the x. My answer, remember, is going to be a point, so my answer is going to look like this boxed in answer right here. Now to figure out the other number, I am going to go back to the original equations, and the easiest way to do this is to go back to the equation where you had that y all by itself. That's going to be the easiest. Technically, I can go back to either of the original equations, but this one would be easier. So it tells us that y equals 6 times x, and I now know what x is. X is -1. So if I want to figure out what y is, all I have to do is 6 times -1. I'm doing 6x, 6 times x, and I'm going to get -6. And so our answer for this one is the point, -1, -6. All right, let's do another one. Let's go to number 3 next. Now, if you take a look at number 3 over here, on the top equation, they have the y all by itself, okay? So that means the easiest thing to do is we're going to take the y equals x plus 9, and we're going to take this x plus 9 part, and we're going to substitute it for the y in the other equation. All right, so if I look at the other equation, I have 3x plus 8y. Now instead of y, I'm going to substitute x plus 9. And that should equal -5. All right, now for this one, we've got distributive property going on here. All right, so +8 times +x and +8 times +9. So distributive property. Now I'm going to combine my like terms. And now I have a two-step equation. So I'm going to do a -72 to both sides. I'm going to add that up and keep that sign, and then I'm going to divide both sides by 11, and x is -7. Now you can get decimals or fractions for some of these numbers as well, so that is possible that that would happen. All right, now again, to get the second number in my point, I am going to go back to the equation where I had the variable by itself. That's the easiest way to go. I could go back to this 3x plus 8y equals -5. That would work as well, but this is always the easiest. So to figure out the y, all I have to do is x plus 9, and I now know that x is -7. So all I have to do is -7 plus 9, which is 2. And now I have my answer of -7, +2 for that point. All right, third one I'm going to do with you is number 1. Now, number 1 is a little bit of a different kind of problem. I mean, it's the same problem, but it has a uniqueness to it. I have two equations, and they both have the same variable by itself. Okay, so y equals 4x minus 1 and y equals 2x minus 5. So what I'm going to do is I'm going to take, it doesn't matter which one, equally easy, but I'm just going to do the top one. I'm going to take this and I'm going to substitute it for the y in the other equation. You always have to substitute into the other equation. All right, so now what I would have is 4x minus 1 equals 2x minus 5. So I'm substituting that 4x minus 1 in for that y. All right, now I have like terms on opposite sides. So the first thing I'm going to do is a -2x to both sides. And now I have a two-step equation. And then I'm going to divide both sides by 2. All right, and for my answer, I'm getting that x equals -2. Now, to get the other number, again, you can go back to either equation. I like to go back to the equation where I isolated the y and I used the piece to substitute into the other equation. So I'm just going to use that top one. But I could use the bottom one too. So it's saying that I can find y by just doing 4 times x minus 1. And we just figured out that x was -2. So that's going to be -8 minus 1, which is -9. And so we get for our answer -2, -9. So this is, again, called substitution. We learned how to do this graphing, and now we're learning a new technique. And we will also be learning a third technique called elimination.